Hello, thank you for watching my video. This will be part 3 of solving linear systems, and this will cover elimination. So as from before, we knew that we can solve linear systems by graphing. We can solve linear systems using substitution, and we can solve them through elimination. Now elimination is new to me. I only began teaching about 3 years ago, and I actually first learned elimination then. I don't remember when I was younger, in my younger years in school, learning elimination, but it is by far the most interesting in the way that it works. And so let's get started. So as you can see here, we have two equations with y equals negative 3x plus 4 and y equals 3x minus 2. The way that elimination works is that we add the equations together, and we let me demonstrate. So here, I'll bring them over here. Okay, so I have the two equations here, and now I'm just going to add them together. Now we have a y and a y, and they're both positive, and so we're just going to bring them. If we brought these two together, two positive numbers, so let's say this was a 1 and this was a 1, if we brought two positive ones together, we would get, of course, a positive 2. Of course, they are y's, so we're going to call it 2y. So 1y plus 1y equals 2y. The next thing is we have negative 3x and a positive 3x. If we bring these two things together, if we add them together, we get a negative 3 and a positive 3. Well, a negative 3 and a positive 3 cancels each other out, and so these go away. Last but not least, we have the positive 4 and the negative 2, and if we bring these together, we get a 2, or 4 minus 2. The other way to look at it would be 4 plus a negative 2, which would be the same as 4 minus 2, and that would be equal 2. Now, now that we have this equation, we've eliminated, so we've done exactly what we said we were going to do. We eliminated the x value, and we have just the y value. So we divide by 2, and y equals, here, let me write my y better. Y equals 1. Now, how do we get the x? Well, if this is indeed a linear system, the solution should work for both problems. And so much like we did earlier, when we plugged it into the x value, we can plug it also into the y value. And so over here you see y equals 3x minus 2, and so I'll just go ahead and plug that in and see what happens. So y equals 3x minus 2. Okay, and so we're going to plug the 1 in here for the y instead. 3x minus 2. Okay, so now we have to solve for this x. We need to get rid of this 2. We need to bring it to the other side. So I'm going to add 2, add 2. These are going to cancel out, and this is going to become 3. We have that equals 3x. Okay, we're going to get rid of that 3. Divide by dividing. Divide both sides. We get x equals 1. Now, because this is a linear system, it should work for both equations, and so we're going to try this solution over here and see if we get the same 1. So I'm just going to rewrite it down here. Y equals negative 3x plus 4. I'm going to put negative 3 in there. Okay, we have x plus 4, and then this 1 goes into the y spot. Okay, so we're going to go ahead and subtract that 4. Subtract that 4. We have 1 minus 4, which is negative 3, and these two things cancel out. We have negative 3x. We have to get rid of that negative 3, and so because the negative 3 is in front, it's multiplied. So we do the opposite to get rid of it. We divide by it. So basically take this and bring it down here. And of course the balancing rule says we do that to both sides. And we get x equals 1. Now, as you can see here, 1, which is the xy value, the solution, does work for both problems. Okay, and that is it. Thank you for watching my video on solving linear systems using elimination.